Hello class, it's Mr. Cablan here, and today I'll be talking about what's called the distributive property. And some of the things that you are going to see in this lesson, do recall some of the stuff that we did with exponent laws, so just keep that in mind as we're going through today's lesson. So let's get straight to it. So with the distributive property, what you are going to see in all the examples we're going to be looking at today is the fact that you will have a number or a term which consists of a number, letter, or a combination of the two that will be distributed to what's inside a set of brackets. And we're going to look at various questions that outline the details behind that. So let's get started here. So what happens when we have what's called the distributive property? So as I said before, when you have a set of brackets and there's a term in front of it, whether it's a number, a letter, or a combination of the two, what you're going to do with that term is multiply it to the two or more terms inside the brackets. So this A is going to multiply itself to this X, and this A is going to multiply itself to this Y, and that'll give us a combination of AX plus AY. Now, it'll make a little more sense once we start looking at numbers, but that's ultimately what the distributive property is. Now, once you distribute the term to the terms of the inside of the bracket, the bracket is no longer there. And another thing that we're also going to revisit in this particular lesson is what happens after we perform the distributive property, and we're going to revisit the gathering of like terms. So when we do that, again, we are multiplying the term to whatever's inside the brackets. Okay, that's also known as expansion. And like I said, once you do that, if you need to, you would just need to gather the like terms simply by putting them together and then simplifying the expressions from there. And one thing that, since we are dealing with multiplication, is that when there are numbers involved, basic multiplication will be happening. And you notice in this next point here is apply the exponent laws to variables. So when we multiply two of the same variable together, you're going to see that the exponent laws, specifically the addition of the exponents, will come into play when we see that particular example. All right, so let's get this started here, and let's start it off with the basic example. And as you can see here, what we have in each case here is a number in front of a set of brackets. So let's do the first one here. So what I'm going to do with that 5 is multiply to the x and the 1. So when we do that, 5 times x will give me 5x, and then 5 times 1, that's going to give me 5. So for the final answer there, we would get 5x plus 5. Now keep in mind that this is the final answer because 5x and 5 are what are called unlike terms. So what we have there is a term with a variable or a letter and a number on its own. We cannot combine those two together. Now, part B is exactly the same thing. Just have to be a little bit careful because we are multiplying this time the terms in the brackets with a negative number. So in this case here, we're multiplying -2 to the x and -2 to the -5. So since we are multiplying the negative number to another negative number, you're going to see that the rules of integers do apply for that one. So when we multiply the -2 to the x, that gives us -2x. But when we multiply the two negatives together, that's going to give us +10. Okay, and again, that's the final answer because we cannot gather those two terms together. All right, this next one here, the only difference with this one, notice that we now have 3 terms inside the brackets, but the rules don't change. The only difference with this question here is that you're going to multiply the number to the x squared, the -7x, and the 4. Now, you probably see already that when you multiply a number to a variable, all that's doing is it's putting the number and the variable together. So for example, 3 times x squared, that's going to give me 3x squared. Now, when you multiply the 3 to the -7x, you are multiplying the numbers together. So for example, 3 times -7x, that's going to give me -21x. Then for the final part here, 3 times 4, that's going to give me 12. Now, what you have here is an example of what was called a trinomial because there are 3 different terms, okay? And again, if you have an x squared and an x term, such as this question, you cannot group those together because the x's have different exponents attached to it or a different degree. Now, put a star beside part D here because you're probably looking at this question, well, it looks like we have a minus sign in front of a set of brackets. Well, we're pretty much done the question, right? Well, in this case, it isn't. Anytime you see a negative in front of a set of brackets, okay, what's really there is a -1. So what you're going to do in this example is you're multiplying a -1 to the x squared, a -1 to the 3x, and a -1 to the -4. So this will give us a final answer here of -1x squared, -3x, and +4. And again, you cannot group those terms together because they are all unlike terms. Now for part E, the only one slight twist to this one is the fact that the first bracket happens to have the two terms, and that second bracket only has the number, but the technique is exactly the same. The only difference in this case here is that we're going to take what's inside the first bracket and multiply it to the 4. So for example, we're going to take the 3x, we're going to multiply that to the 4, and we're done with that. And we're going to take the 1 and multiply that to the 4. Now when we do that, 3x times 4, that gives me 12x, and then 1 times 4 gives me 4. Okay, so ultimately, even if you took the 4 and you put it in front of the 3x plus 1, the answer would be exactly the same. All right, so now you've seen what happens when you multiply a number in front of a set of brackets. So let's now see what happens when we're multiplying a variable or a combination of a number and a variable that makes up the term in front of the brackets. Okay, so in this case over here, what I want to do recall is the fact that anytime you see an x, there's really an invisible exponent 1 attached to it. Now I said at the beginning of this lesson that when we multiply two of the same variable, the rules, the exponent laws now come into play, specifically the product rule, where you multiply two of the same variable and then you will be adding the exponents. So in this case here, when I multiply the first x to the x inside the bracket, remember that each x has an exponent of 1. Since we are multiplying the two x's together, the ones from each x are going to add. So what we wind up getting here for when we multiply the two x's will be x squared. And just like the previous examples, anytime you multiply a letter to a number, you're just grouping the number and the letter together. So the final answer to this will be x times x, which is x squared, and then x times 2, that's going to give you 2x. Now keep in mind that anytime you multiply a variable to a number or a number to a variable, which is the letter, the number always goes in front of the letter, such as this 2x. Whatever you do not write down the number after the variable. All right, for part B, we're now multiplying the x to an x squared, an x to 7x, and this x to the negative 14. Now remember that anytime you multiply two of the same variable, the exponent law, specifically the product law, comes into play, where the exponents then add. So if you take a look at the x over here, that x in front of the brackets, remember that x has the invisible 1, and we're now multiplying it to x squared. So keep that in mind when we come up with the solution. So when I multiply the x squared, what you're doing there is you're taking the exponent of 1 and you're taking the exponent of 2 and adding them together. So that winds up giving us x cubed in the first term there. Now when I multiply the x to the 7x, just focusing on the x's for a moment, when I multiply those two x's together, we wind up getting x squared because each one has an exponent of 1 and we're adding those two exponents together. So when we do that, that's going to give us a total of 7x squared. And last but not least here, when I multiply the x to the negative 14, that's going to give me negative 14x. So you can see that as long as you remember the product rule from the exponent laws, when you multiply two of the same variable together, all you're doing is changing the value of the exponents. Now also remember, for part B, notice that we do have 3 sets of x's. However, since they have a different exponent or a different degree, we cannot group those x's together. All right, so for this last one here, we're now not only do we have a variable, we also have a number in front of it, and that number happens to be a negative. So be very careful when you're distributing this negative 5x. So when you distribute this negative 5x, we're multiplying it to the x squared, we're multiplying it to the negative 3x, and we're multiplying it to the positive 4. So when we take that negative 5x, when you multiply it to the x squared, okay, what you're doing there again is you're taking the exponent of 1 and the exponent of 2. Okay, since you're multiplying the two x's together, those two exponents will add. So what we wind up getting there will be negative 5x cubed. Now be very careful with this next one here because we're multiplying negative 5x to negative 3x. So let's focus first on the negative 5 and the negative 3. When the negative 5 and the negative 3 multiply, since both of them are negative, it then becomes a positive. And since you have the negative 5x, the x itself has an exponent of 1 and you're multiplying it to another x, which has another exponent of 1. When you add those two together, it gives you an exponent of 2. So the final answer for that will be 15x. And don't forget, it's going to be a positive. And last but not least, we're going to multiply the negative 5x to the 4, which gives me negative 20x. So you can see here in that last question there, I combined a negative term in the front as well as a variable. So you can see that when you do get in a scenario like that, you just need to be a little bit more careful when you're distributing a negative term, specifically one that also has a variable. All right, so what we're going to do now is we're now going to see what happens when we have to both expand and simplify. So what we are going to revisit in these examples is that after we distribute the numbers or the term to the terms inside the brackets, we then need to gather the like terms simply by grouping. So if you take a look at A here, the first thing we're going to do here is multiply the 5 to the x and the 5 to the 4. So 5 times x gives me 5x, and then 5 times 4, that's going to give me 20. Okay, so that's going to be what happens when we distribute the 5. So the next thing we're going to do here, we're going to distribute the negative 2 to the x and the negative 2 to the negative 7. And don't forget, just be a little bit more careful when you multiply the negative 2 to the negative 7, because since you're multiplying two negative numbers, your resulting answer there will be positive. So what we wind up getting here will be negative 2x plus 14. Now, if you take a look at the terms here, you notice we have 5x plus 20 minus 2x plus 14. So what we want to do next here is to collect the like terms, and I like to use shapes for that. So the first term we're going to gather are the x's, starting off with the 5x, and the only like term there is the negative 2x. So I'm going to write those side by side. Now keep in mind when you do this step where you write the terms side by side, the signs do not change. All I'm doing is that in this case here is I'm taking the 5x and the negative 2x and just writing them side by side without adding any additional signs. Okay, and the only two terms remaining, the two numbers, they are like terms because they're numbers. So we have the 20 and the 14. I'm going to write those side by side. And last but not least, we just need to gather and simplify the like terms, starting off with 5x minus 2x, which is 3x, and then 20 plus 14, which gives me 34. So the final answer to this will be 3x plus 34. Now you notice just before we proceed to the next example, we started off with two sets of brackets, two sets of expansions. We wound up with 4 terms in one of the intermediate steps, and then after we gathered the like terms, we wound up with 2 terms. All right, this next example, just be a little bit more careful when distributing because we are dealing with a negative number. So in this case here, we're distributing the negative 2 to the x and the negative 2 and the negative 3. And for the second set of brackets, notice there's a little space there just to give you a clue in terms of what you have to put there. And what you're going to see here is that anytime you see a negative or a positive for that matter in front of a set of brackets, there's always going to be an invisible 1 there. So in this case, we need to be careful when we distribute that because what we're distributing there is a negative 1. All right, so we're going to start off with negative 2. We're going to multiply the negative 2 to the x and the negative 2 to the negative 3. So that gives me negative 2x plus 6. Okay, and the next part here, we're going to distribute the negative 1 to the 5x and the negative 1 to the negative 1. Okay, so again, when we multiply the negative 1 to the 5x, gives me negative 5x, and negative 1 times negative 1 gives me positive 1. All right, now that we've distributed the terms, we just need to gather them now, starting off with the negative 2x here. So the only like term to negative 2x is negative 5x, which I'm going to group together. Now, when I group the negative 2x and the negative 5x together, that then becomes subtraction. So that's going to give me negative 2x minus 5x, which we're going to simplify in the last step there. And then we have the 6 here and the 1, which are like terms. Gather those terms together. So negative 2x minus negative 2x minus 5x gives me negative 7x, and 6 plus 1 gives me 7. Again, 2 different terms, which you can no longer simplify any further. All right, so for this next part now, we're going to throw some fractions. Now, if you have your calculator in front of you, by now, I should have introduced you to the fraction key. So I will show the steps on the side here, just to, again, just to show you what's happening when you do that step here. And the distribution of fractions is no different than the distribution of whole numbers over here. It's the exact same thing. Okay, the only difference in this case here is that when you distribute the fraction, okay, you are multiplying it to whatever's inside the bracket here. So starting off with the first one, we're going to multiply the half to the 4x and a half to the 10. Now, whatever you do, do not take the fraction and change it to decimal, okay? In some cases, it might give you a repeating decimal and it gets a little bit messy from there, okay? So keep the fraction the way it is and I'll show you why. So when we distribute that 1 over 2 to the 4x and the 10 over here, what's really happening here is that you're multiplying the 1 over 2 to the 4x separately and the 1 over 2 to the 10 separately. So starting off with 1 over 2 times 4x, okay, if you punch that in your calculator, you'll see that when you multiply the 1/2 to the 4x, you wind up getting 2x. And you're probably wondering, well, how does that happen? Well, what happens over here is that when the 1/2 multiplies itself to the 4, okay, the 2 and the 4's cancel out. And then what you have there is 4 divided by 2, basically, and that'll give me 2. So that gives me 2x for the first term. And for the second part over here, you have 1/2 times 10, which is the same thing as 10 divided by 2. That gives me 5. So for that first part here, notice what we have here will be 2x plus 5, and we no longer have any fractions to worry about for this example. Okay, next thing that we have here, we're going to take the 3 over 4 multiplied to the 8x, and the 3 over 4 multiplied to the -4. Now for this one over here, okay, if you do it in your calculator, that's great. You can actually do it in fewer amount of steps here. But when the 3 over 4 multiplies itself to the 8x, okay, you're going to see that the 8 and the 4 cancel each other out. However, what's happening here is that you're looking at the 8 and the 4 over here, and you're dividing the 8 by the 4, okay, which gives me 2. So what you wind up getting there in the end there is that you're going to multiply the 3 to the 2, and that will wind up giving you 6x. Now, like I said, if you use your fraction key in your calculator, okay, it'll do all that for you. Okay, so I'm just breaking down in terms of why the answers why they are. All right, so when you multiply the 3 over 4 to the -4, the 4 and the -4 cancel out. Actually, the 4 and the 4 cancel out, and you're left over with -1. And then 3 times -1, that gives me -3. So what we wind up getting there will be something that looks like this. Okay, notice that I've just simplified what I have in the brackets there, and that's going to give me 6x minus 3 there. Okay, now as I mentioned before, if you use the fraction key in your calculator, okay, and you input everything correctly, it does all of that for you. All right, now, no longer, as you can see, we no longer have any fractions, and we only have to collect the like terms in the final step here. So let's take the 2x and the 6x, add them together. Take the 5 and the -3, group them together. And then from here, just simplify the x's and the numbers separately. So 2x plus 6x is 8x, and then 5 minus 3, that gives me 2. And that's pretty much it. And you notice, again, we start off with fractions, 2 sets of brackets, and we wound up with an answer that only consisted of 2 different terms. All right, so the next thing I want to do here is what are called nested brackets. And what nested brackets involve, as you can see in the example here, is that we have a square set of brackets, which are the nested brackets, okay, and we have a round set of brackets that are inside. Now recall when we did the order of operations, BEDMAS, okay? When you're dealing with brackets, you're always starting off with the inside brackets first, and then you work your way out. And that's exactly how we're gonna approach this. So for example, if you focus on the square brackets here for a moment, and you focus on the brackets on the inside, okay, notice that within the brackets, there's a 5 that's lingering on the outside. So our first step here is to distribute that 5 to the 2x and the 5 to the 1. Now you notice there's a -3 in front of the square brackets, which tells us that we don't actually have to deal with it until the final step here. So 5 times 2x is 10x, and then 5 times 1, that's going to give me 5. Now, from here, you're now going to bring in the -3, and we're still inside the brackets. Now, what you want to do here is to simplify what's inside the brackets as much as possible. If you take a look inside the nested square brackets over here, what you can simplify in the next step here is the 5 and the -3. Okay, so all you're doing here is 5, and then you're subtracting 3 from it, which gives me 2. Now, just to double check, we have simplified everything inside the brackets to two, in this case, 2 distinct terms. So the final step of this one, you're now going to multiply the -3 to the 10x and the -3 to the +2. Okay, and that'll give us a result here of -30x minus 6. So you can see that when you have brackets inside the brackets, always start off with the ones on the inside and work your way up. All right, so the last example we're going to look at again is a word problem. Dealing with one of the #1 producers of all time, DJ Khaled. So what we have here is 4 music producers, and they teamed up to produce the most popular radio song in history. The record label negotiates the following contract with them, and you notice there's 4 names listed there. Now, what we have here for all the four producers are the expressions which represents how much they get paid. So we have Diddy who gets paid 20,000, and you notice there's nothing else other than that. So that's basically all he's going to get paid. We have Swiss Beats who gets paid 10,000, and a royalty of 2N, where N represents the number of albums sold. Khaled himself, he gets paid $15,000. Okay, and he gets paid $1 for each album sold. Now there's an invisible one in front of N, that's why I said $1. And last but not least, Boy Wonder, he doesn't have a fixed rate, but he gets paid $3 for every album sold. So what we want to do for this first example is to write out a simplified expression for the total payout to the producers. So this is just another way of saying what we're going to do here is to gather the like terms, and we're going to do exactly that in the order that you see them. So starting off with Diddy, he has 20,000. Okay, now Swiss Beats is 10,000 and an additional 2N. So we're going to add those two expressions to the 20,000 that's already there. Okay, next part here, we have Khaled's expression, which is 15,000 plus N. And then we have Boy Wonder by himself, we're adding another 3N to it. So anytime it's asking you for a simplified expression, the tendency is for you for this question to tell you to add all the expressions together, which we did in this example. Okay, in the next example, we're going to gather like terms starting off in the numbers here. So we're going to add the 20,000, 10,000, and 15,000 together, like so. And that will give me 45,000. And we're going to take the 2N, add a 1N to it, and add the 3N, which gives us 6N. So anytime you're adding expressions together, okay, please make sure that you gather the like terms, because that is the most complete answer you will have for a question just like this. Now, for the next part, we're now going to use that expression to solve the following question. It says, calculate the total payout when there are 1,200 albums sold. Okay, what I tell people to do here is always start off by writing down the expression first to see exactly what you need to replace. So in this case here, N represents a number of albums sold. So what we have to do for this question is to take the 1,200 and then substitute it in for the yen. Okay, and then from here, we can now simplify that by putting it in our calculator, and that gives us a total here of $52,200. So you can see how we can take a word problem, come up with a simplified expression, and use that simplified expression to come up with answers to certain questions depending on what the value of a variable is. All right, so that wraps up the distributive property. Okay, so you can continue working on the workbook or on the textbook questions, and I'll see you in the next one.